Hey, welcome back. I hope you had a chance to go through the other video and maybe practice a little bit. Sorry, it was a long video and some of it's a little tricky. Write down your questions. You can see, I hope, how important it is for us to get together live a few times a week. We're just going to talk through, hey, I don't understand this. I'm not going to let you say I don't understand anything because I think you do. And I think we just need to maybe walk through some together. So hopefully those examples that I do, you write down and you do them as well. And then we'll get a chance when we're live together as a group to practice. When we did talk last time, all right, we did an example like this where I might have an angle in standard position that doesn't terminate in the first quadrant. So it's not an acute angle. It's bigger than that. In fact, it's bigger than an obtuse angle, which is between 90 and 180. This one goes all the way around into the third quadrant. And what I told you we can do, and we're going to talk about now, is this angle T, which is a really big angle. We can actually find stuff about its sine, cosine, tangent, all the trig functions by using this angle down here. I drew a little theta in there. Hopefully you could see that. But we'd make a right triangle over here down in the third quadrant and just use that angle. That's called a reference angle for angle T. Let's run through the notes real quick. It says non-quadrantal angles have a reference angle. This is the acute angle formed by the terminal side and the x-axis. Have a look up here. Here's the x-axis. Okay, on this side it's positive, this side it's negative. But this angle over here is formed by the terminal side of the angle and the x-axis, in this case, the negative x-axis. That's called a reference angle for angle T, okay? It's always positive. When we list terminal angles, we'll always list them as positive. Sometimes we have to do that whole coterminal angle thing. You're going to remember that once we go back and practice it to find a simpler angle. But you're going to have to use your smarts, and I know you can, to figure out how do we find a coterminal angle. This is what I mean. Let's stay in degrees for a little bit because you guys are more comfortable in degrees. If I knew that angle T here was 210 degrees, okay, I want to write 210 degrees here for angle T. What would be the measure of that angle theta, that reference angle? Think through that. I wish I could ask for a hand raise because I bet some of you could come up with that. It's like, it's clearly going to be this whole angle, 210, minus this part, which is 180. So it's going to be 210 minus 180, or 30 degrees. That's how I would find that reference angle. On the other hand, if the reference angle were up here in the second quadrant, let's have an angle in standard position that terminates here, all right? I always make the reference angle with the x-axis. So in this case, this would be my reference angle theta. This is my angle T. Let's say that T was 140 degrees. How do I find my reference angle theta? Somebody figured it out. In this case, I would take 180 degrees and subtract the 140 degrees. And my reference angle theta, if this was 140, my reference angle would be 40 degrees. You might want to practice that in each quadrant. The first quadrant, the easiest, because whatever the angle is, that is also what the reference angle is. They are one and the same. In this quadrant, okay, here would be angle T going all the way around. and that is ugly. This would be my reference angle. I make it always with the x-axis. So here's my angle theta. And if this was 345 degrees all the way around to here, T is 345 degrees. Someone shout out, even though I can't hear you, what my reference angle would be. It would kind of be all the way around 360 degrees minus 345 degrees. Theta, my reference angle, would be 15 degrees. All right. So finding your reference angles just a little tricky, but I think you guys can do that. Always just look to make an angle with the x-axis, either the negative x-axis if it's here or here, or the positive x-axis if it's here or here. And we just kind of subtract from 360 or from 0 or from 180 over here, and we come up with the reference angle. Maybe just a little bit trickier when we're in radians, but we're getting used to that. Here's an angle in standard position, an angle T. Let's say that measures 2 pi over 3 radians. Okay, my reference angle is going to be made with this terminal side and the x-axis. This is going to be my reference angle. And I find it by taking this angle here minus this angle. All right, this angle, it's 180 degrees. How many radians is that? Pi radians minus that angle. So I have pi minus 2 pi over 3. Let's find out what my reference angle is. I need a common denominator. I'm going to say this is 3 pi over 3 minus 2 pi over 3. Turns out my reference angle is pi over 3. Okay, once we find reference angles, life is going to be really, really good for these bigger angles. So let's jump in. Let's practice a couple. Please have a piece of paper out. You can have your calculator out if you got to do some quick math, but most of it we should be able to do on our own. But we're going to just find some reference angles together. If you have your books, you can open them. If not, I'll try to write down the questions. Example 5, I'm on page 542. It says, find the reference angle theta for each of the following angles. They call it theta with like an apostrophe, theta prime. No big deal. That's just a symbol they chose to use. But my original angle is first 345 degrees. So in other words, they want us to find the reference angle for an angle that's 345 degrees, which I totally did not mean to pick just a little bit ago. That was a coincidence. But hey, we'll go with it. If you need a visual, 345 degrees, that's 90 degrees, that's 180, that's 270. 345 degrees is going to be all the way over here. And so my reference angle, they call it theta prime, whatever. My reference angle is going to be 360 minus 345, 15 degrees. Again, we just did one like that. I didn't mean to pick the same thing, but I need to know that the reference angle there is 15 degrees. Okay. B, we're going to do one in radians now. 5 pi over 6. Okay, that's where it starts to get a little bit tricky because we are either going to have to draw it out to see kind of where it is, or we're going to have to start playing around. 5 pi over 6 is a little less than 1 pi. Hopefully you remember 1 pi radians is 180 degrees, so it's going to be a little bit less than that. And so if this is my angle, how to find this reference angle, I've got to take 1 pi minus 5 pi over 6. And I need a common denominator, so let's go with 6 over 6. My reference angle is pi over 6. Again, that's going to be really helpful, really important. It's going to make your lives easier. So practice finding these reference angles. That's going to be a huge thing. Next one is in degrees. It's negative 135 degrees. Again, our directions here are find a reference angle, and we're given negative 135 degrees, right? If I need a visual, standard position, except this time we're coming this way, we're coming negative. This would be negative 90. It's more than that. This would be negative 180. So it's somewhere in between here. And that's negative 135 degrees. Okay, the reference angle is the angle I'm going to make here with the x-axis. And so how do I find that? Well, one way might be to find a coterminal angle. Another angle that ends right here, but isn't negative 135 degrees. Let's add 360. Let's add a full loop around. And when I add 360 to 135, oh goodness, no, I'm not going to do math in my head real quick. Okay, forgive me for having to do that quick on the calculator, but its coterminal angle is 225 degrees. So if I had gone this way, it would be 225 degrees. Doesn't change my reference angle. My reference angle is the one right here. What's that going to be? 225 minus 180. 45 degrees is going to be my reference angle. All right. I think we'll keep it with just those examples, angles, whether it be in degrees, a little bit easier, or in radians, a little bit more challenging. But we're either going to do, if my angle is here in the second quadrant, we're going to do 180 minus my angle, or pi minus my angle. If it's here in the third quadrant, we're going to do the angle minus 180 or the angle minus pi. Over here in the first quadrant, no worries. The reference angle just is whatever the angle is. If it's in the fourth quadrant, we do 360 degrees minus my angle, or 2 pi radians minus my angle to find the reference angle. Good luck. Happy hunting. Write down your questions. We'll go over any questions together.